Hi everyone, I'm going to review page 13 in your packet. So if you take a minute and flip there. If you need this, I drew these special right triangles at the top just to remind you of the formulas as I go through these. But hopefully by now you do have them memorized and it's a little bit easier for you to find all the missing sides. Okay, so number one, we have a 30, 60, 90 triangle. Okay, and they give us the short side. So just a reminder, I would label what you're given. We know that our short side is always x, so we have x equals 2. So this one's pretty easy. We know our longer side is the shorter side times square root 3. So b is just taking our x value times square root 3. And our hypotenuse, which is c, is always 2x. So we're just taking 2 times 2, which is 4. So that's our answer for number 1. Number 2 is a 45, 45, 90 triangle. Okay, remember, we know these angles are congruent. They're both 45 degrees. We know the sides, or the legs of the triangle, are both x, and they are both going to be the same. Okay, so I'm just going to put x equals 3 for both of them, which means that our b value is 3. This is the easiest scenario of the 45, 45, 90 because you have those sides. The hypotenuse for those is always x square root 2. So you're just going to take your 3, put it in front of your square root 2. Okay, so that's 1 and 2. Number 3 was 30, 60, 90. We are given the hypotenuse on this one. So when you're given the hypotenuse, okay, you want to start with that. Okay, our hypotenuse for the 30, 60, 90 is 2x. So you want to solve for x here. Okay, once you set it equal to it. So that's going to tell us that x equals 2, which remember, that's our shorter side. So our a is 2. Okay. Our longer side is always the shorter side times square root 3, which is just x times square root 3. So I'll write this down. So you're just taking your 2 that we just found and plugging it in for x. Okay, so b is 2 square root 3. Okay, number 4 is a 45, 45, 90 triangle. So I'll put our degrees in here. This time you're given the hypotenuse, and we need to find the legs. So start with taking your hypotenuse and say, okay, we know the hypotenuse is equal to x square root 2. Okay, we want to start with finding our x, which is going to give us our legs. To solve for x, you're just dividing both sides by square root 2. So I'm going to come down here and make this look a little bit nicer. You have 4 over square root 2, but we want to rationalize the denominator, get rid of that square root 2. So we're going to multiply the top and bottom by that. So we have 4 square root 2 over 2. Okay, and then reduce that to 2 square root 2. So we found that our x, which is our legs, are both 2 square root 2. And it's always good to label your triangle because remember, you want to solve completely for these special right triangles. Okay, so that's number 4. Number 5 was a 30, 60, 90 triangle. This one you're given the longer side first. So you want to take the 6. We know that the long side is equal to our formula, x square root 3. Okay, we want to solve for x. So just like number 4, we want to get rid of that denominator, get rid of the radical. So divide both sides by square root 3. So we have, let me rewrite this, x equals 6 over square root 3. We want to get rid of that radical. Don't leave that in the denominator. So you have 6 square root 3 over 3, which reduces to 2 square root 3. Okay, so that's our x value, which is our short side. So that means our a is 2 square root 3. Okay. So now we're going to use that to find our hypotenuse. We know the hypotenuse of the 30, 60, 90 is 2x. So I'm going to put 2x here. So we're just taking the side we just found and multiplying it by 2. Okay, so 2 times 2 square root 3. Remember, you're just multiplying the 2's in front. Leave that radical 3 alone. Okay, so your hypotenuse would be 4 square root 3. Okay. And if you have further questions, please email your teacher and we can explain in more detail if I'm going too fast. All right, number 6 is a 45, 45, 90. So remember, again, both those angles are 45. We are given the hypotenuse on this one. We need to find the legs. So you're going to start with taking your hypotenuse. Let's set it equal to the formula, which we know is x square root 2. Okay, we're going to solve for x. So you should have divided both sides by square root 2. Now this one works out nicely because square root 2 divided by square root 2 is just 1. They cancel. Okay, so both of your legs, the A and the B, are both 1 in this case. Okay, so again, that's easy. You don't have to get rid of any radicals in the denominator. Okay, number 7, make this a little bit bigger. Okay, is a 30, 60, 90 triangle. We have that the hypotenuse is 1. We're looking for the shorter side and the longer side. So again, start with the side you're given. We know that the hypotenuse is equal to 2x. So set 1 equal to 2x. Okay, we're solving for x, which is our shorter side. So you end up with x is 1/2, which is a, because again, that's our shorter side. So a is 1/2. Okay, we're going to take that and we are going to solve for our longer side. Okay, the longer side, which is b, is x square root 3. So you're just taking 1/2 that we just found in a, that's our x value, times square root 3. So it's 1/2 square root 3, which you should write as square root 3/2. Okay, number 8 is a 45, 45, 90 triangle. We have the hypotenuse is 1. We are looking for the legs. So we're going to start with, we know our hypotenuse is equal to x square root 2. We're going to set it equal to what the hypotenuse is, which is 1. To solve for x, divide both sides by square root 2. So x equals 1/square root 2. We're going to rationalize the denominator, so multiply the top and bottom both by square root 2. So in this case, you end up with square root 2/2 for both of our legs, which is our A and our B. So again, the 45, 45, 90 triangle is a lot easier because once you find the leg, that takes care of both your A and your B. Okay, so that's 8. Let's look down at the bottom 3. The bottom 3 say find the following in fractions reduced to lowest terms. So now we're going to review SOHCAHTOA, which I know you did this in your notes. I think it was 2 pages ago. Okay, so if you need to write out SOHCAHTOA, okay, as your review from geometry, which we're hoping you remember, please write that out and always remember to reduce your fractions as much as you can. Okay, and also in all of these, you want to make sure that you're going from your theta, which is your degree. So number 9, okay, based on where theta is, we need to find the fraction for sine of theta. Remember, sine is always opposite over hypotenuse. So here's the opposite side. Okay, it's the side right across from it. And then, let me highlight this. Our hypotenuse is 5. Okay, remember, hypotenuse is always the side across from the right angle. All right, so if you need to write down that sine is always opposite over hypotenuse, go ahead and write that down. Your reduced fraction is 3/5. Okay, so let's look at cosine. Okay, Cosine of theta is always adjacent over hypotenuse. Sorry, that's messy. We're looking at the adjacent side. So remember, adjacent is right next to. So right next to theta is 4. Okay, right next to it, but obviously not the hypotenuse. Over our hypotenuse, which again, the side across from the right angle, which is 5. So the cosine of theta is 4/5. Okay, the tangent of theta. Okay, tangent is always opposite over adjacent. Okay, the side opposite theta is 3. The adjacent side is 4. Okay, remember adjacent is right next to. Okay, so our tangent theta is 3/4. Another thing you could do if this helps you, when you see where that reference angle is, if you would like to write down, this is the adjacent side, this is the opposite side, this is the hypotenuse, you may absolutely do that. Okay, if you don't need to, that's fine as well. I know sometimes in geometry you guys label. Okay, number 10. Okay, so this one, a little bit of a different scenario here. We have a 30, 60, 90 triangle. So I want you to go ahead and fill in your 60 degrees here. We need to find the trig functions, the sine, cosine, tangent, etc. of these. But we're missing our long side and our hypotenuse. So you want to start with what we're given. Okay, we know that the shorter side is 1, which is our x. Okay, to find our b, which is our longer side, you're just taking x times square root 3, which is really just square root 3. Okay, to find your hypotenuse is just 2 times x. 2 times 1 is just 2. Okay, so the first thing you want to make sure is that you do have all of your sides and you know what special right triangle that we have. All right, so I'm going to highlight those to make this easier for us. All right, now we want to pay attention to the degree that they're giving us here because that's important. Okay, so I'm going to put our degree on 30. Okay. So we're finding the sine of 30 degrees. Okay, so again, looking at our 30 degrees, sine is always opposite over hypotenuse. The opposite of 30 degrees is 1, and remember our hypotenuse is 2. Okay, so our reduced fraction is 1/2. And if you want to label your adjacent, opposite, hypotenuse, you can. Cosine of 30 degrees. Again, we're going from this 30 degrees. Cosine is always adjacent over hypotenuse. So the side next to 30 degrees is down here, okay, which is square root 3. And the hypotenuse is 2. Okay, so that's already reduced. All right, tangent of 30 degrees. So again, going from our 30-degree angle, tangent is always opposite over adjacent because it's TOA. Okay, so the opposite of 30 degrees is 1. Okay, the adjacent, which is right next to, is square root 3. Now make sure you don't leave your answer like this. Again, we want to get rid of that square root. So multiply the top and bottom by square root 3. So you have square root 3 over 3 is your tangent of 30 degrees. Okay, so the next 3 are referencing our 60-degree angle. So I'm going to highlight our 60 degrees. Okay, so now our opposite and adjacent are going to switch. The hypotenuse always stays the same. So sine of 60 degrees. Okay, we're looking for the opposite over the hypotenuse. So our opposite is square root 3. Our hypotenuse is 2. Okay, that's already reduced. So that's our solution for sine of 60. Cosine of 60 is adjacent over hypotenuse. So the adjacent side is 1. Let's write this over here. And our hypotenuse is 2. So again, adjacent over hypotenuse. And then the tangent of 60 degrees is our opposite over adjacent. The side across from it is square root 3. The side next to it is 1. And that simplifies to square root 3. Okay, so that's number 10. Let's look at number 11. Okay, number 11. Very similar to number 10 in the fact that we need to make sure we are writing in our 60 degrees here, and we need to find our missing sides. So this time we have the longer side. We know that the longer side is 3 square root 3, which remember, our longer side is equal to x square root 3. Okay, so let's solve for our x here. That way we have the shorter side. So these are going to cancel, these are going to cancel. So our shorter side is 3, which is a. So hopefully this is getting easier for you. And then our hypotenuse is always 2x. So 2 times that value. 2 times 3 is 6. Okay? All right, now, to find our sine, cosine, and tangent here, they are only asking for the sine of theta, and actually the cosine theta and tangent of theta. So we don't have to do as many on this one. Sine of theta is opposite over hypotenuse. So if we draw our arrow here, okay, you guys can label. Here's the opposite side, and then here's our hypotenuse. Here's the adjacent. So our opposite side is 3. Our hypotenuse is 6. Because sine is always opposite over hypotenuse. Please reduce that. So you leave your answer as 1/2. Okay, the cosine of theta, okay, adjacent over hypotenuse. So we have 3 square root 3 over 6. Okay, you want to reduce your fraction. 3/6 is 1/2. So square root 3 over 2. Okay, tangent of theta, all right, is going to be opposite over adjacent. So the side opposite is 3. The adjacent side is 3 square root 3. Now, we don't want to leave our square root 3 in the denominator, but we also can reduce. We can cancel out these 3's. So I'm first going to make it as 1 over square root 3. And then remember to multiply the top and bottom by square root 3. So you end up, we're going to make some more room here. You end up with square root 3 over 3 as our tangent theta. Okay, so hopefully that helps with page 13. Again, if you have additional questions, please email your teacher, and we can do a Zoom video with you or create another video. Thank you, and everyone stay safe and healthy.